Good day, grade 11s. Again, this is another video on Newton laws. So this is November 2020, question 3. So we're gonna do now this one. I think this is a second one. The other one was November 2022. So I'm gonna read you the statement now. The statement says, a 250 Newton force is applied on a block of mass 25 kg. The 25 kg block is connected to a 10 kg block by a light inextensible string through a frictionless pulley as shown in the diagram below. The 250 force acts at an angle of 25 to the horizontal, so that the system of blocks accelerate to the left. The coefficient of a kinetic frictional force between the 25 kg and the surface is 0.15. Okay, let us try to dissect what the statement is saying. So here they said the frictional force for the 25 kg block, this one is 0.15, and this system, they told us it is accelerating this way to the left. So let us now check the forces that we have. We know the 10 kg block is a hanging object, and the hanging object always has two forces. There is a weight, and then there is a tension going that way. Now for the 25 kg block, we know we have the tension in opposite the tension of a 10 kg block, and then the surface and the object is having the kinetic frictional force, and then there is the weight of this block, which is that way, and there is the normal force, which is this way, and then we have this now diagonal force, which is 250 Newton. So I call that the applied force. Now what we know about the applied force has two components. It has F of y, which is vertical, and it has F of x, which is horizontal. These are the two components of that force. So these are all the forces that we have for the 25 kg block. Before we even go to the questions. Okay, now let us go now to the questions. Okay, 3.1 says, define the term kinetic frictional force. Define the term kinetic frictional force. Okay, let's look at 3.1. The definition of a kinetic frictional force, we say kinetic frictional force is the force that opposes the motion of a moving object. It's a force that opposes the motion of a moving object. Relative to the surface. Yeah, so this was 3.1. Now let's look at 3.2. 3.2 says, now draw the free body diagram of all forces acting on the 25 kg block. Now you look at the number of marks. It's 5 marks. That means there are 5 forces that you must indicate when you are drawing your free body diagram for the 25 kg. Okay, so for 3.2, so we indicate our object with a dot. Then let us do the first force. The first force will be our diagonal applied force. So we label it as F. Then the second force would be the normal force. The third force will be the weight. So this one is your normal force, then this one would be your weight. Then we have 2 other forces that are looking this way to the right. So we have the tension and we have the kinetic frictional force. So these are your 5 forces that are acting on that object. So you will get your 5 marks now for the 5 forces. Now let me just indicate the components of this force. You know, F has 2 components. We said it has the F of X and it has the F of Y. So I indicated these 2. They are not part of the free body diagram, but I just indicate the 2 because I'm going to need these forces later on. So let's go to 3.3.1. Calculate the normal force exerted by the surface on the 25 kg. Calculate the normal force exerted by the surface on the 25 kg block. Now they want us to find the value of this, the normal force. Now for this diagram, we normally know that if an object is on the horizontal surface, the normal force of this object is equal to the weight. But if there is a force now diagonal on the object, since this force has that component which is F of Y, so now we cannot say the normal force is equal to the weight. In this case, there are 2 forces that are looking up. There's one force that is looking down. So we say the normal force plus the vertical component of the force minus the weight is equals to 0. So in this case, the normal force will be equal to the weight minus the vertical component of the weight. Sorry, the vertical component of the force. So the normal force is equal to W minus Fy. So that's what we're going to do here for 3.3.1. For 3.3.1, 3.3.1, 3.3.1, yeah. So we say the normal force plus Fy minus W is equals to 0. Remember, in this case, since the object is moving to the right, so it's like up is positive. So this normal force is positive, the F of Y is positive, but the weight is negative. So you can look at it as up is positive. That means down is negative. So then N is equals to, take the weight to the other side, is going to be positive. Take Fy to the other side, is going to be negative Fy. And the weight is mg. Fy is F sine of theta. What is the mass? It's 25. What is the g? It's 9,8 minus. So we need now to check the angle. The angle was 25 degrees. The angle is 25 degrees. So that means we have, or the force, what was the magnitude of the force? 250. So the force is 250. So we have the force 250 sine, the angle was 25 degrees. So this is the calculation we are going to do. Take the calculator. So we have 25 multiplied by, okay, let's do it like this. Let's put a bracket, 25 multiplied by 9,8, close the bracket, then subtract, open the bracket, 250 sine 25, close the bracket. So the answer is 139,35. 139,35 newtons. So that was our normal force. Then let's quickly go to the next question. The next question says, calculate the acceleration of the system of blocks. Now you look at the number of marks there. It is 7 marks. So surely we are going to use simultaneous equations here to find the acceleration of these two blocks. So let us see now. We have this is your 25 kg block. So let me quickly draw the vector, the freeboard diagram of the other block. I think the other block is like 10 kg. Yeah, it's 10 kg. So this is the freeboard diagram for 10 kg. It has the weight, and then it has the normal force. The tension. Yeah, so now we have to find the acceleration of these two blocks. So this is your 10 kg block. So what is the first step that you do? So what you do here, you must separate your blocks. I'm going to look at the first block. Remember, it's going to the left, so I'm going to take left is positive. If left is positive, that means the right is negative. So it's going this way, it's going to the left, so it's positive. That means the one that is 10 kg, which was going up, so that means up is positive since left is positive. Okay, so the first step that we do, we must say, okay, we are looking now at the 25 kg block. So I'm focusing at the 25 kg block. So the first formula that we have, always we use the Newton's second law, which is F net is equals to ma. That is the formula that we use. So we're focusing now at the 25 kg block. So F net means we must look at the sum of horizontal forces. In fact, it's a sum of all these forces, but focus mainly on the horizontal forces because they are the ones that are causing the block to move either to the right or to the left. They will cause the acceleration. That's what the law says. So in other words, we are focusing now. This one, the f of x is going to be positive because it's going to the right. So this one is positive, because going to the right. Then there is this one, the friction. The friction is negative because it's going to the left. The tension is negative because it's going to the left. So we are focusing on this one, the friction, and f of x. These are the only three horizontal forces in the free body diagram for the 25 kg block. So let us include now these ones. So we say f of x is positive because it's going to the left, and the left is positive. Here is it, left is positive, but the frictional force is going to the right, so it is negative. The tension is going to the right, so it's negative. So these two forces are pulling the object to the right. This one is pulling the object to the left, equals to ma. Then we need to find now the values for the force and the angle, because f of x is f cos theta. The frictional force, we know it is the kinetic coefficient times the normal force minus the tension, equals to ma. So we're going to substitute now for all these that we know. We know the force is 250 newtons. Cos, we know the angle is 25 degrees minus. They gave us the kinetic coefficient. I think they said it's 0.15. The kinetic coefficient, yeah, they said the kinetic coefficient, here is it, it is 0.15. That is the coefficient of the kinetic frictional force. So we know that one, so we're going to substitute it there on our kinetic coefficient. So we substitute this one as 0.15 multiplied by the normal force. We have already calculated the normal force for the 25 kg block. We find to be 139.35. 139.35 newtons minus, we don't know the tension, so we're going to leave it as the unknown. The mass now is 25. We also don't know the acceleration, so we're going to leave it like that. So we have two unknowns here. So let's simplify our calculations. Let's find the value for the first one. Take the calculator. We have 250 cos of 25. 250 cos of 25. The answer is 226.58. 226.58 minus, let's calculate the other one. Yeah, we have 0.15 multiplied by 139.35. So you have the answer as 20.90. This one is 20.9025. 20.9025 minus t equals to 25 times a is just 25a. So these are the like terms, then we can add these two. So we have there 226.58, 226.58 subtract 20.9025. Then we have 205.6775. 205.6775. We don't round off, we're going to round off at the last stage. Minus t is equals to 25a. Then let's leave t here as negative. Let's take the value to the right. So we have 25a minus, remember this one is positive on the left, so on the right it's going to be negative 205,6775. Then let us now divide by this negative. So negative divided by negative is positive. Positive divided by negative is going to be negative. Negative divided by negative is going to be positive. Yeah, so this is equation number 1. So let's leave this one. So this is the first t, so it's t1 or it's t25. So let's look at now at the second block, which is 10 kg block. The 10 kg block. So we also said F net is equals to MA. So we already know for the 10 kg block there are only two forces. We said there is the T tension is going up, so the tension is positive and the weight is negative. So let's substitute now these two forces. There are only two forces acting on the 10 kg block. So the tension is going up, so the tension is positive. The weight is going down, so it is negative. Also equals to MA. We don't know T. We can find the weight. The mass is 10. We don't know the acceleration. So T is equals to 10 times 9,8, which is equals to 10A. So we have T minus 10 times 9,8. 10 times 9,8, I think is 980. Let's confirm. Oh, sorry, it's 98, not 980. Yeah, it's 98. It's 98, which is equals to 10A. Yeah, so let's take now that 98 to the right. So we have 10A plus 98. So we're going to make that equation number 2. So this is our second tension, is T2 or T10. So now the third step now is to say let T1 be equals to T2, because there are two unknowns here and there are two unknowns there. So whenever you have two unknowns, we use simultaneous equation. What is T1? Here is T1. It's negative 25A plus 205,6775 equals to, what is T2? T2 is this one, which is 10A plus 98. So now we have this. Now we have this and that as like terms. Negative 25A and positive 10A are our like terms. So we're going to put the like terms on the same side. 25A minus 10A. Then 98 and that number is a like term. I'm going to put it on the right. 205,6775. So if these are like terms, 25 and 10, which is negative 35A. Then let's subtract these two. So on that other side we have 98. Subtract 205,6775. So you have negative 107,6775. Negative 107,6775. So you can see now we have a negative 35A on the other side, negative 107,6775. So we divide now by negative 35. We divide that side by negative 35. Then we find A, these two cancels. Then let's divide the other side by negative 35. Divide by negative 35. Negative 35. So we have the answer as 3,08. acceleration is 3,08 meters per second square. You can see that is also moving to the left because it's positive. Now, we have not yet answered the question. The question said we must find, is it the tension? I'm not sure whether they were asking the tension or just the acceleration. Let's just check again. Where am I now? Okay. Let us check the question again. Just want to move this to the left. Okay. Oh, the question said let us just find the acceleration. Okay, they just wanted the acceleration, they didn't want the tension. But just for interest's sake, in case in the future they ask you the tension, the last step now would you have done that you have to do in order to find the tension. After you got your acceleration, if they ask you the tension, what you can do now to find the tension is just to take this acceleration. You just have to take this acceleration and then you substitute it there to find your tension. Or if you want, you can take it, you substitute here. It's gonna give you the same value for the tension. Okay, yeah, that's all for today. Then I'm gonna see you in the next video.